So here, the next question that we have is asking us to determine whether each integral is convergent or divergent. Evaluate those at convergent E. So here's an image that we can see. Maybe it's giving us more information. So we'll save this. Okay. So here the function we're given is as follows. The integral between 1 and infinity for, so let me just write that down. E the negative square root x over root x dx. Okay. Okay, so this is the function, or sorry, the integral that we need to figure out if it's convergent or divergent. So the first step we want to do is kind of figure out how to evaluate the integral. And then to test for convergence or divergence, essentially when we evaluate the integral, if it gives us a constant value, it will be convergent. And if it gives us an infinite value, so negative infinity or positive infinity, we know that the integral is divergent. So those are the two cases. So to evaluate this integral, we're going to use substitution. So here we can see that we have a square root x on the top, and we also have a negative square root x up here. So we're gonna have to use that to substitute a value for this in order to better evaluate the integral. So here we start off by saying u is equal to negative square root x. You'll see why this is the case in a moment. So we'll also say du, we'll take the derivative here, over dx will equal to negative 1 over 2 square root x. So whenever you evaluate, you do the derivative here. So this is technically 1. This is also equivalent to negative x to the half. So to evaluate this, we can multiply it, we subtract a half from here, and then we multiply the half in front. That's how we get this derivative. So we subtract a half by 1, and that'll give us x to the negative a half, and then we multiply a half to the full component here, and we'll actually end up with negative a half. Well, let me just write that a little clearer. So we'll get negative half x to the negative 1 over 2. So here we know when it's a negative sign in the exponent, we can put it at the bottom, and that's kind of what we've done over here. We just put it the value at the bottom, or the variable at the bottom. Okay, so now that we've got this portion, so we've set u to negative square root x, and now we have the derivative of u. So we're going to rearrange this equation, and it'll give us 2 du equals dx over square root x. So we've done this step to make it easier for us to substitute dx over square root x into the integral. So we'll take this down here. So the first component that we can substitute in is u is equal to negative square root x. So we'll say the integral of e to the u. And then the bottom here is we want to substitute this part of the equation. So we're going to substitute this with this. Okay, and that will give us negative 2 du. So we'll have the du over here, and we can pull out the negative 2 to the front. So now we have a more simple integral here. So there should be a u here that we can evaluate. So the integral of e to the exponent u is just eu. So we have negative 2 eu. And we have to evaluate this at x equals to infinity and x equals to 1. So let's just clear up some space up top here. Okay, so to do this, we can substitute back what we originally set u to. So we originally set u equal to negative square root x. So we can substitute this back into our equation down here. So we can say that we can take because there's an infinity component, we can take the limit here. So the limit of b, let's say, to that when it tends to infinity, of the function negative 2 e to the negative square root x is a bracket at b to 1. So here, because we had an infinity component, we just took the limit and we put a variable up top here. Now we substitute in b and 1, so we'll say the limit as b goes to infinity. So I'll put this in square brackets. So the first component, we can actually, to make it a little simpler, we'll just take the negative 2 to the front. So we'll say in the beginning here, we'll say is equivalent to negative 2. And then we'll say that we're evaluating e to the negative square root b, subtract e to the negative square root 1. We'll erase this down here. So what we'll have is the negative 2. So when we evaluate e to the negative square root b, we can think of b tending to infinity. So here we say that it could be 1 over, because it has a negative component, e to the infinity essentially, because b is infinite. So here we know this component will cancel out to 0, because we have 1 on top and then we have infinity on the bottom. So we know this component is very, very close to 0. And then the next component will be 1 over e to the 1. So the square root of 1 is just 1. And we know that the negative allows us to put the e on the bottom. And then we're left with 2 over e. So because after evaluating this integral, we got a constant value. So we got 2 over e. E is just a value of 2.7, and there's more digits after that. We would get a constant, and that means our integral is convergent. So let's say in a scenario where our final value was infinity or negative infinity, for example. In this scenario, it's not. Let's say it's infinity or negative infinity. If we evaluate a different integral, that means we know that that integral is divergent. We know in this scenario, it converges. So here, to demonstrate whether integrals converge or divergent, we need to check whether one exists or not. It exists. Okay, so Here it tells us the process doesn't give us a full solution, so no solution given integral is convergent. Process described.